Right, so sorry for the short delay on getting this started, but I figured this time round I will just take this opportunity to kind of give a quick overview with the engine, where we're at so far. I know it's been a long time since I've actually done live streaming, especially on Twitch. So some of you may know I had a quick switch over to Mixer, which I wasn't too happy with. Just a bit of a, dare I say it, dead platform, so won't be doing that again. I think I'll be staying on Twitch from now on and focusing purely on that, and just focus on getting these live streams done rather than getting like the most views or whatever it is. The most important thing for me at this point is consistency. Getting these live streams to the point where I'm doing them not daily, but most days in the week. I think my current schedule has 4 live streams scheduled every week, and I'm going to try my best to hit that. I won't most weeks, I don't think. Yeah, I really want to try and hit that milestone, and then upload excuse me, then upload those to the YouTube channel, which will go up roughly on the same schedule, but there will be a bit of a delay while we get those edited and get thumbnails drawn up for those as well. But there won't be much behind it. At most it'll be like a week or something like that. But yeah, rather than waffling on, I'll jump into basically where we're at with the engine. And a lot of progress was made since I've last shown this off, and I'm sure you'll agree. So the voxel smoothing algorithm, while I wouldn't say is game complete, I would say that it's complete in terms of the current implementation. Same with the basic brush system that we have, and I'll show that off, and various other bits and bobs as well. The UI is obviously placeholder and is something we'll get rid of, but let's increase the brush size slightly. Here we go. Let's say we're painting with the brush. This is the kind of like quality and behaviors that you can expect, which I think is really nice. One thing that you'll notice as well is as you're placing these, it'll take like some time for the smoothing to catch up. And that's simply because of the new implementation of the smoothing algorithm. Now, I won't go into a lot of detail as to how that works, because while it isn't boring necessarily, it's a lot of detail to go into that I have covered on other live streams. But basically I fixed it now, it's all working. Rather than do what I was doing before, which it was to do the smoothing immediately after the brush had been placed, the engine now waits for all of the current brushes to have been placed in the world, and then it will play catch-up smoothing out, so it will smooth out everything as opposed to just one small section at a time, which saves a lot of time obviously when not having to repeat the same block over and over again, although it still does do that to some extent, just not quite. There are some lag issues which I will look at fixing again at another time. That's just when large amounts of voxels are in the scene, but that's only because these are not actually hollow as they should be, which will be something that will be worked on in the future. There's kind of a culling method to clean up the engine a bit, make it a lot more efficient, and kind of put the voxel engine really in the background rather than something that's a really in-your-face issue currently. But right now my focus is on getting props working, so that not only can we have a usable demo at some point, but also just so that we can really start to see the engine kind of come to life and start making little scenes within it, so that we really have something to work with and show off. Because at the moment it is nice to mess around with, but you are limited, and obviously we don't want that. We want something that really kind of shines, especially when trying to kind of visualize stuff, like with AI for example. I'm going to need environments in which the AI can operate, so that's why props are a focus now. And also the prop system will lay the groundwork for the AI system at a later date. And what I mean by props is essentially there will be models, and it's essentially an interface to interact with the models that we'll have in the world, so things that aren't these key kind of voxel shapes that aren't tied to the engine directly. So yes, they'll be able to be placed in the world, much like the voxels are, but they won't be implemented in the same way, although they will respect the confines of the voxel engine. so you won't be able to place them freely, for example. They will have to be placed on the snap system, at least initially in the editor, and then once obviously moving over to gameplay, certain props will follow slightly different rules. Maybe some might be physics objects, that kind of thing, but the implementation of that isn't necessarily fixed just yet. It's something that I'll be experimenting with as we go, kind of as we decide we need it, rather than waste lots of time building a complicated spec and then maybe not using half of it, because we really don't know where we want it to go at this stage. We have a pretty good idea, but nothing 100% concrete. So more than anything, I'm just focusing on getting it to the point where stuff can be placed in, game can be ran, stuff is maybe interactable, maybe it can move of its own accord, that kind of thing. So the first stage in this is designing the controller interface. So I'll be doing that using the header file, and I think this live stream I'll just be focusing on doing that. I won't delve too much into implementation, if at all, just so that we can really get a solid idea of what we want it to do, at least initially, rather than spending loads of time working out the details of that immediately and then having to revert changes because we might have realised we want something else as well, or something doesn't quite work with in conjunction with another feature. So the reason this is currently commented out is because I didn't want it to interfere with me showing it off. But I've essentially made a small start on this already, so I'll just run through some of the things. So obviously we've got the spawn in new prop. We want to know if physics are enabled on it, so whether it's like a static object in the scene or not. And we also want to know what prop ID we're using, so what item it actually is that we want to spawn into the scene. We'll have a list like as a reference, all of the different prop types, some kind of dictionary that I'm sure will come in handy, especially when Josh is using it as a designer. There's obviously the accompanying delete prop. There's change prop type, which will just find the prop instance in the scene, so that's the ID that the individual object will have, whatever it is, maybe it's an free or whatever, and then also the new prop ID that we want, and it'll inherit all of the position values that are already in there. So there's not really any point in replacing a prop. If you're going to place it in a different place, you might as well delete it and spawn it in. I can't think of any case in which you want to do that, unless maybe for like offsets and stuff like that, but that will all kind of be considered in the back end. So change prop model state. So this is cycling through any maybe variants on a model. So let's say there's damage states in the engine. We can store multiple of those models inside of an object and then cycle through those. Same with animations. There could be multiple animation states or animation like cycles that can be run through, and again this will just toggle which thing you're using at any given time. So that'll just basically say whether or not the animations are running for that object. And I believe, now we've not done too much research into animations just yet within the Unreal Engine, but if we do decide to use the built-in ones, what we'll be doing is tying different animations to different model states, and then this will just be like an on-off switch essentially. So it's nothing too complicated. We want this controller to be as simple as possible until maybe any complications come up with the way it works in Unreal Engine, but that's implementation specific, and we don't know what the implementations, or at least I don't know what the implementations are going to look like yet, so I've not researched every aspect of it. I kind of like to work as I go. And I work under the assumption that there won't be any massive curveballs in designing this. Obviously there will be, but for now I just want to keep it simple so that it's easy to follow. Same with toggle prop physics. That'll just define whether or not the physics are turned on. That will be useful particularly for AI, because they'll want to obviously interact with the environment and won't be fixed on the voxel snapping, such as with other objects. So there's move prop position as well. So this essentially is moving where it is in the scene, nothing fancy about it. This will most likely become a private function. unless I can think of a reason not to, and then that will be hidden behind things like accelerating and decelerating, well, same thing really, changing velocity and that kind of thing. So in fact I'll add those in now, and then I'll explain what this thing is that I was working on before, which might have to change. So let me think. So we want most of these are running off of a bool return, and that's just because we want to know whether or not the action has been successful. So bool, let's say we've got we want set velocity is a good one. Although it's something ideally that should be avoided unless there's a good reason for it. You'd want to kind of accelerate it as with normal physics. You don't just set a velocity on an object, generally speaking. And I want to kind of follow, not real world physics obviously because that's a bit of a stretch, but simplified real world physics to an extent. It does, while the game may look cartoony, you want it to follow certain expectations so that the player can find it intuitive. So obviously we want to take in what thing it is we're targeting. And then also the 3 velocities on the, I might as well just copy this, the 3 velocities on the different axes that we want to change it by. And then basically we're doing exactly the same thing, but for acceleration as well. And it is that simple, pretty much. There's nothing really that we want to do in terms of overcomplicating this too much. So right, so to go into detail as to what this is, this will have to be reworked massively because it doesn't behave the same way that the other system does, but this was actually copied in code from the Voxel system that I kind of renamed basically slightly. I've not really done much work on it yet. I wanted to save that for now. But we're actually going to look at another piece of code that I have in, I believe it's in Terrain Controller. So if we can find the section that handles, there's a lot of code in here, but I'll find the section that handles deferred loading. So to quickly explain, deferred loading is adding things to be loaded into the game to a queue rather than loading them all in a frame, so that it doesn't cause hangs on individual frames. Basically, there's a system that I've built to fix a lot of the issues we're having with lag when spawning voxels in, which you may be able to see when it's smoothing out. It takes a bit of time to catch up, and it happens over a number of frames rather than all at once. So if we look at the implementation for the terrain controller, you'll notice there is a queue somewhere. So we'll need the header for the queues. Let's find which one that is. So it's just simply that, I think. Nothing too fancy. Then we'll want to go into, I'll close editor camera for now, just to make things a bit simpler while we're working on something else. So basically this will be rewritten to be individual items rather than arrays, because we're no longer using an array system, we're using a queue system. And queues will be added in as an alternative to internal arrays to store a potentially infinite list of props. Obviously we'll probably cap it at something for performance reasons, but that's basically what we're doing. So we'll just add that in. So we want queues in there. We also want, so we want a queue of the type struct that we have, so it's a similar layout to this basically. So copy this line and we'll just rename stuff. Also forgive me if my programming is a little rusty, I've not actually done this in some time, just because we had quite a big break over the Christmas period. So if I'm a bit rusty here and there, it's just I've not done it for a while. But I'm sure I'll get back into the flow of things now that I'm going to try and live stream more regularly. Also got my trusty mug again, keeping me company. I kind of like this as a mascot, so I always seem to have it. Just see if I need anything else. Don't believe so. Right, so now we need to work out basically what each individual thing is going to have. Like I say, these aren't arrays anymore. They're just variables. So that isn't a bool. I think I copied most of this and didn't really retool anything, so I might actually just rewrite this all out. But essentially, we're going to need it's just the first thing that popped to mind. Also, so we've got obviously got the velocity. I could store this as, let's see how I've done it in the camera controller, because it'll be easier to copy that implementation if it's already there. Does it have a velocity? I'm fairly certain it did. An F vector. I'll use an F vector instead then. Obviously don't call it camera velocity, call it velocity, obviously. Another important note is the ID of the object will be its position in the list. So, what should it be? I'm thinking, right? In fact, yeah, you know what? What I will do instead is I will have a list of, sorry, an array. I'll use an array for this implementation, and I'll give it a kind of hard limit. So what this kind of allows me to do, no, it's not great for all implementations, but I've kind of weighed up my options when it comes to using lists versus arrays for like things like object storage. And I prefer arrays for a number of reasons, mainly because it's fixed indexing. There's also no dynamic resizing of the list, which is more efficient when saving and loading things, especially large numbers of objects. It also means that I'm kind of forced to have a hard object limit, which can be good in kind of limiting your expectations of objects in a. It's not always practical depending on what kind of implementation it is that you're going for. Maybe you want potentially infinite objects, but we don't in this case. I will change that to 128, no, 256. Okay. So I will have that amount of props for now in my system. So we've got prop velocity. We also don't need anything else. I don't think. Prop acceleration. What else do we need? So we've got the model state, so we'll also need some kind of model storage. So I need to think about what kind of implementation I want for that. If we want potentially multiple models, then obviously we'll have to convert it over to some kind of list, but for now I'm just going to copy a similar implement previously with terrain pieces. If I remember correctly, that was a uInstant static mesh component. So we don't want to use that. Not immediately, at least, anyway. Though should we? So this is one of the design decisions that I basically need to think about. Sorry, I just replied to a message quick. Sorry about that. Right, so look. So yeah, this is one of the things that I need to kind of question as to how I'm going to do this, because obviously if I've got multiple models with multiple models, I don't want them to kind of be lagging out the scene, especially if it's lots of the same thing. But if we're using lots of unique models, then in that case, uInstant static mesh components, which I've spoken about before in detail on other live streams. So if you want to kind of catch up on and research, go ahead, because I don't have time to explain it again. Which sucks, but it just is what it is. I don't also want to repeat myself a lot on these, because it will be a waste of time, I think, for you guys if you've already seen stuff before. So this could be, for example, used for things like trees. Obviously with trees there's a lot of repetition in scenes. And I think the goal that we have is to make as heavy use of reusing the same assets as possible, so that when you guys are using the editor, you're not overwhelmed with options, and we don't need to make incredibly detailed scenes, just functional ones. So I think it might be a smart idea to use the instant static mesh components. Just don't know if the overhead in terms of memory cost is worth it, but it's not something that I really have enough time to mess around with. So I guess what I'll do is I'll just go for one implementation, see how it is. Yeah, just go from there basically. There's no point spending loads of time deliberating over stuff like this, especially when I'm trying to do rapid development. So if I go to here, again we want a place to store. We want a place to store all of these. We also need the header for that, which is, yep. Oops. Always do that, press Control B all the time. Let's put that in there. All that prop models, keep it simple. And then we also want a define as well. So what I'm probably going to do is centralize my defines at some point, just through inheritance. Sorry, I'm Mr. Popular today for some reason. Basically when I'm doing these I kind of need to keep an eye on other chats that I've got going, especially if Josh is talking to me, so I do apologise if I seem rude. I'm not trying to do. So yeah, let's add some defines in. So we want defines for the what do we want? The other time I had models and materials for the different kind of like material types that we have, because every voxel has, every material is applied to every voxel shape in a set, but we don't have that this time. So what we do is we just simply have model variants, which will be one dimension rather than two, so we can actually get rid of one of these. We just have lots of model variants, and then if we want additional materials as well, we'll just make another place adjacent to the model is we've got saved in memory. So let's say caps lock on. Yeah, right, so model format. It's not necessarily a great idea to use hard-coded values, but since I'm the only one really developing this, I think it's something I can manage for now. There we go. Top model found. So now we have a storage location for them, and for here I will probably want some kind of ID just to say what thing it's actually using. So, oh, actually I don't know why I deleted that, I need that. Ah, that's why it's not showing up, it is not capitalized correctly. Put that at the top, we want int. Prop model ID, so that's the current prop that it's current model that it's using. And I don't know if I need any other things. Obviously position as well would be a good thing to store, but that's internal to the engine, so I don't need to store those. This will just add a model into the scene whenever something's updated. Maybe the position in the list that's been made, an ID for what model it is. Static mesh. So that basically just is a number reference to where in whatever static mesh list it is that I have, whereabouts it is, so I can find the model that I've instantiated in the scene and actually manipulate that. So that's all fairly simple, I think, and it follows some of the things that I've learned from here. Let's see if there's anything I've forgotten. So world center we don't need to worry about. I might hard code that value in as well at some point. We've obviously got the material. Rotation's not important because we can use the model as a reference for that. Visible mesh ID, that's something that we've got implemented already, and shape ID, that's something we've got. I don't think there's anything else. What I'm going to do now is just have a look through some of the other functions I've got in here and see if anything stands out to it.
People that are different have a shot at being original. You know, they got motivation too. You know, they got motivation.
No, one thing I've just remembered I also need to do is I need to have a integer list or an integer queue, just some kind of storage model for what voxels it occupies in terms of its shape. Although that being said, might be worth doing that through collisions. I basically need to work out a way to tell the engine whereabouts it's occupying so that pathfinding can avoid it, but that might only make sense for static props. Then what if you get a big physics-based prop, would it matter? Paint's always good for this kind of thing. So let's say we've got, I don't know, a tree I'm going to draw the world's worst tree. Excuse my drawing, I don't even know what I'm doing. There we go. Okay, a bit fuzzy. You can tell I'm a programmer, eh? Let's say we've got a tree. We want to plop it in the scene. We want AI to navigate around it. Especially if we've got lots of trees as well, actually. Would it be best to use some kind of local navigation or some kind of hybrid? You know, I'm really not sure. So this is one of those things where basically this video is going to be me thinking about something for a long time. I will try and illustrate my thought process a little bit. So obviously we've got this grid of voxels, right, that the AI has to navigate at some point down the road. My issue currently is, how do we tell the engine where these models are, particularly if they have physics on them? And then the question becomes, how do we decide what props have physics and which ones don't? Is it a separate thing? Is it the same class but used in a different way with maybe different settings? So my initial thinking was, for each model type, we tell... So imagine this is one model. We tell the engine roughly what we expect it to occupy in terms of voxel volumes, and then static props will always be oriented either on exactly on a voxel position and on the right rotational plane for it to fit in that voxel engine. So it knows where to go. So if we do this, which I think is a good idea, because then AI will be able to navigate smoothly around the engine, even if props are in the scene. What we'll have to do is have some kind of list. So if you bear with me 1 second, I'll just get up the... I have a better idea, actually. This is a simpler idea. Something that can be searched through a bit more efficiently, and makes more sense in terms of grid layout. So what we'll do is we'll have a Boolean volume, with the center point being the origin. So we'll have a Boolean three-dimensional array. So imagine it's like a grid internally. I don't need to draw the whole thing out, but you get the idea. What we'll do is we'll have a Boolean flag for each position. Center will be the origin point, so it needs to be an odd number of storage places. This bounding box will be the maximum size that a prop can be, so that will be a setting that I edit. And we'll set each flag when we're loading in an object, saying which voxels it occupies, basically. So we'll work outwards from the middle and do it that way. So let's say, as an example, we want the maximum voxel size to be... Let's say we're not going massive for now. We can always change this later. So three wide. We want to double its height because remember this voxel engine uses half height voxels. So let's say 7 just for simplicity's sake, and 3 again on the other axis. So this will be its maximum potential volume, these numbers here. And this just means we can quickly check the flags for a position local to an object, and see whether or not it's occupying a certain space, which I think is quite a nice way to manage this. I think a nicer thing to oh no, don't worry. I don't want to overcomplicate things any more than they have to be. So I think this is a nice simple solution to the problem. It might cause issues later on, but again, it's something that I'll solve when I get to it. I don't want to worry too much about the implementation details of something cases. I think if there's any other pressing issues. We've got all of the kind of generic spawning stuff in, we've got some of the moving stuff in, we have all of this stuff. We'll also want a way to be able to search for objects in the scene. So maybe if we, inside of the Voxel engine, have a list of objects. No, again, it's overcomplicating it at this stage. So that's basically all I wanted to run through this time round. I really didn't want to overcomplicate it that much. I just literally wanted to go through the quick design of what it is that we'll be kind of working on over the next few sessions. Basically just implementing these functions and getting them into a basic state so that we can create a basic. And then I'll be starting work on the editor side of it so that you can actually use in-game camera to spawn these items, which we may or may tie into a primitive UI, but I don't think so. So really starting simple. Moving forward, like I say, I want to keep these more regular. I also want to keep them a bit shorter than they were before. I think more often but more concise is kind of the best way to go, and it also means that it's favourable on like the YouTube algorithm and all that kind of thing. And these live streams are digestible. So if I'm doing them at a regular time, obviously you can hop on for an hour, not get bored with me talking and rambling on about stuff that I've already covered previously. I can just get straight to it, work on the thing that I'm working on, and show it off to you guys, and also give you quick updates if I've changed anything in between. So I can spend more time programming off camera and doing what I consider more kind of high quality work. Or maybe not even high quality work, but more complicated work. Sometimes I work better when I'm forced to talk, more often than not, which I somewhat am with these live streams. So what I will be doing is, like I say, keeping these as more of a brief update, also maybe doing some implementation details moving forward. So I hope this has been somewhat informative, and I hope it's been a nice, brief, but good introduction to what it is that I'm doing currently. I will again show off quickly the engine and its current progress. One thing I didn't mention before is obviously we've got this new material system in, and you can see that there's different colours on the sides and the tops. That's quite easy to change. You can add any material you want onto those. In addition to that, let's say we have a voxel and it is... Let's scale this up quickly. So let's say we have one of these underneath voxels. We can change the appearance of the bottom one relative to the one on top. So let's say this is a grass block. Rather than the bottom of the grass block also being green, we could maybe make it, I don't know, maybe have roots in it or something, so that from underneath it doesn't look like a grass block, it looks, or rather the top of a grass block, it looks like the bottom of a grass block. So those are independently changeable now, which is a nice little addition to the engine that kind of came about as part of the system that I was working on. So yeah, I hope that this has kind of been cool to see. I love the fact that I can finally show this all off and that it works. I think this was finished over Christmas, and I got the last major bug ironed out with the deferred spawning over that period of time. So I'm really happy that this is all working now. And I hope that you guys like it so far. A proper like kind of demo video will be coming in the near future, and also this is just showing off that you can also delete them. I don't think any voxel engine would be complete without being able to delete them. And I think this is even cooler than spawning them in, to be honest, because you can make like caves and stuff and see how it smooths out. So it's really fun for me to be able to play with what I've been working on for the last... Well, overall it's been 6 months, but solid development work, it obviously hasn't been anywhere near that much time. But yeah, this is really cool to be able to see. So yeah, I think I'm going to wrap it up there. Thanks for watching, basically, and I hope to see you in the next few days. Bye.